You know that specific kind of panic when you drop your glasses on a dark patterned rug?
Oh, absolutely.
You know they're right there, but you can't see the frames at all. They've completely blended in.
And you end up shuffling your feet hoping you don't step on them.
Exactly. And the only way you find them is by, like, catching that tiny glint of light off a screw or a hinge.
That is the perfect mental image for what we're covering today. Only, instead of a rug, it's the Perseus cluster.
And instead of glasses, it's a galaxy that is, for all intents and purposes, invisible.
Yep. We're talking about Candidate Dark Galaxy 2. CDG-2 for short.
It's about 300 million light years away, and frankly, it's a ghost.
Or at least we shouldn't have been able to find it. Not with the usual methods.
Right. So the mission for this deep dive is to figure out how astronomers managed to spot this phantom in the deep universe.
And what it means for, well, our entire map of the cosmos.
So to get why this is such a huge deal, we have to talk about how we normally find galaxies. It's pretty straightforward, right?
Usually, yeah. We look for starlight. Big, bright, glowing collections of stars. Simple.
But CDG-2 just didn't play by those rules.
Not at all. And this is actually a historic first. It is the first galaxy ever discovered, not by seeing the galaxy itself, but by spotting its accessories first.
Which brings us right back to my glint of a screw analogy.
Exactly. In this case, the screws are globular clusters.
These are those super dense spherical knots of stars that orbit galaxies.
That's them. So David Lai at the University of Toronto, he wasn't looking for the galaxy. He built this statistical algorithm to scan the dark for tight groupings of these clusters.
So he wasn't hunting for the object, he was hunting for the pattern.
Precisely. The algorithm was looking for a little huddle of clusters that statistically just shouldn't be there by chance.
And it found them.
It did.
Yeah.
It flagged 3 or 4 of them bunched together in the void. Once he had that, then they brought in the heavy artillery.
Hubble, I assume.
Hubble for the high resolution, yeah.
Yeah.
And the Subaru telescope, plus ESA's Euclid telescope, to look for any faint background glow.
And that's when the ghost finally appeared.
A very, very faint, diffuse structure surrounding those clusters. It confirmed they weren't just floating alone, they were clinging to a gravitational anchor.
But this is where the story gets really strange. I mean, the stats on this thing are just wild.
Oh, they are. When we say dark galaxy, we are not kidding. The headline number is 99.9%.
Wow.
That's the estimated percentage of CDG-2 that's dark matter. It's one of the most dark matter-dominated objects we've ever found.
So for context, our Milky Way has tons of dark matter, but we also have billions and billions of stars. Why is CDG-2 so empty? Did it just never form stars?
It likely did, but then it got robbed. You have to remember where it lives. The Perseus cluster. That is a chaotic, gravitationally dense neighborhood.
A tough part of town.
Or a very tough part of town. The leading theory is something called RAM pressure stripping.
So the gas literally got knocked out of it.
Basically, it lost all its hydrogen gas.
Yeah.
The fuel for making stars from interacting with other galaxies.
Yeah.
It stopped making stars eons ago.
And that explains why those few globular clusters are so prominent. I think I read they account for something like 16% of the galaxy's entire visible light.
Which is just absurd.
It is. Imagine if your car's headlights made up 16% of your car's total weight. That's how faint the actual body of this galaxy is.
It really highlights how much we miss when we only look for the bright, obvious stuff.
You know, speaking of spotting what others might miss, this seems like a good moment to talk about Embersilk.
Right. If you're trying to figure out where AI agents can actually make an impact, I mean, not just hype, but real utility for your business or in software development, you should check them out.
They specialize in uncovering that hidden potential for automation that isn't always obvious on the surface. You can find them at embersilk.com.
Okay, so back to the invisible universe.
We found one ghost. But this method, looking for the clusters first, it feels repeatable. Are we about to find a whole lot more of these?
I think the floodgates are about to open. We are honestly entering a golden age for this kind of discovery.
Because of the new telescopes coming online, like Roman and Rubin.
That and the AI. We've got the Nancy Grace Roman Space Telescope and the Vera C. Rubin Observatory. These are wide-field survey telescopes. They scan huge chunks of the sky over and over.
And you combine that incredible amount of data with David Lee's statistical search methods.
And suddenly you're not just finding one CDG-2, you might find thousands.
That changes everything.
It really challenges our theories of galaxy formation. It suggests the universe is so much fuller than it looks to our eyes. We're filling in the blank spaces on the cosmic map.
It really leaves you with a kind of a haunting thought, doesn't it? We found this one ghost 300 million light years away.
Right.
But if they're this hard to see out there,
You have to wonder how many are sitting right in our own cosmic backyard.
hiding in plain sight.
That's a question that is going to keep astronomers very busy and probably awake at night for the next decade.
Well, on that hopeful note, if this deep dive sparked your curiosity, make sure you hit that subscribe button.
And hey, leave us a 5-star review if you can. It really does help get the word out.
Thanks for tuning in.